This is solving absolute value with inequalities. Here's the basic outline of things. The most important thing to note is that really you're going to be doing the same steps as you were doing yesterday. The only difference is, of course, there's an inequality sign, but really what you wouldn't take note of is that you're going to solve it slightly differently depending on if it's a greater than sign or a less than sign. And we'll see some examples to understand what we mean by that. Okay, and here I write great or with an emphasis on the word or. Of course, that's not how greater is spelled, but you'll see what's going on with that here in a second. So let's just solve this like we would, like normal. And look, the absolute value is isolated, so I can go ahead and I can split this up into x plus 12 is greater than 2. That's one thing there. Then you're going to, of course, got to do it again where it's going to be negative 2. X plus 12. However, whenever you have the negative 2, you are going to switch the inequality sign. You always switch the inequality sign the second time around. Okay. And now I solve both of these like completely normal. So subtract the 12. 2 minus 12 is, see, 2 minus 12 is negative 10. Okay, and over here again, subtract the 12, and negative 2 minus 12 is negative 14. Now, I said this is greater because whenever you have the greater than symbol, the way that you would write this answer is x greater than negative 10 or x less than negative 14. So it just has to deal with how you would write out that solution, because x can either be greater than negative 10 or it can be less than negative 14. Those two things can't both simultaneously happen at the same time, so we use the word or. Now, the last thing to do is to graph this on a number line, so let me just make a little number line here, and I'm going to pretend, I guess, negative 14 is about right here, and negative 10 is about right here. There's no real preciseness to this here, so I'm just sketching it. Since these are greater than and less than signs, they're open circles. So I'll put an open circle here and an open circle here. And for x greater than negative 10, well, the side of this that's greater than negative 10 is to the right of negative 10. And the side that is less than negative 14 is to the left of negative 14. And so then that's what the sketch of this solution would look like on a number line, meaning that any point on these red lines is a solution. So if you have a less than symbol, then you can see here my super duper clever wording of it as less than. To help us remember, we've got greater and less than. Less than, of course, when you use the words and when I describe the solution. Or there's actually a little bit different way to write it altogether. So again, go through your normal solving steps. I'm going to split this into two inequalities. We've got x minus 10 is less than 4, and x minus 10 is going to be now greater than negative 4, because you always switch the inequality symbol and the sign on the second one that you write. So solve these things like normal, add 10, lots of adding 10, okay. X is less than 14, and x is greater than, let's see, negative 4 plus 10 is 6. Now I can actually combine that together and write that as, taking the smaller number, I can say 6 is less than x is less than 14. Either way that I have this written here is correct. This is correct. This is correct. Obviously, the one that has less stuff to write is probably better to write. So I would say just whenever it's less than, this is how you write your solution down here. Now we still need to graph it on a number line, so let's say 6 is about here, 14 is about here. Again, these are going to be open circles. And the difference with whenever it's less than is that it's going to be shaded in between. So greater than was shaded on the outsides, less than was shaded on the insides. Those are your two basic examples. Now let's look at just two more examples with a little bit more to them. And we'll wrap this video up as soon as we finish those. So, okay, this is isolated, that's fine. Let's split it up. I've got 2x plus 1 is greater than or equal to 7, and plus 1, and I've got 2x plus 1 is less than or equal to negative 7. So now solve these like normal. I'm going to minus 1. Oops, left off that 1 again. Minus 1. Now I've got 2x greater than or equal to 6. And I've got 2x less than or equal to negative 8. Divide by 2. Okay, so I've got x greater than or equal to 3, or x less than or equal to negative 4. Again, because it was greater, we have the word or down there. Now, number line time. So here's my number line, and let's see, my numbers are negative 4 and 3. This time, because these are greater than or equal to, less than or equal to, these would be closed circles that I use. And once again, greater, they go outward. Last example. So, okay, I have a little bit of stuff to clean up before I can split this up. Remember, you have to have the inequality by itself. I'm sorry, you have to have the absolute value by itself before you split it up into two different inequalities. So that means I'm going to add the 1 and then divide by that 3. Okay, well, let's see. You know what, actually I'm going to change the number on this. This is no longer 13. I'm going to make that 14. That way it'll at least come out to be a normal number. So 14 plus 1 is 15. Is less than or equal to 15. And now divide both sides by 3. And I get the absolute value of 5 plus x is less than or equal to 5. So now I split that into my two inequalities. X plus 5, well, 5 plus x, but same thing, is less than or equal to positive 5. And I also would have x, darn it, whatever, x plus 5 is greater than or equal to negative 5. So to solve those, just subtract the 5, subtract the 5. Okay, so then my answers are x is less than or equal to 0, and x is greater than or equal to negative 10, which we would write that as, see, the smaller number is negative 10, less than or equal to x, less than or equal to, the bigger number is negative 5. So this is my answer officially. And then on the number line, it would look like, let's see here, we'd have the smaller one, negative 10 here, negative 5, closed circles, and shaded in between. Okay, so definitely a little bit trickier than your basic solving, but go back, rewatch, especially understand the difference between why we call it greater and less than. It's just our little ways to remember the tricks here for how to write the solutions and how to do the shading and everything. I'll see you in class tomorrow.